Hello world, microcats! Try to expand the capabilities of a microcontroller with a specialized microcircuit. And so we have a touch button that will read its state. 8 red LEDs are used for indication, each has its own current limited resistor. The input-output expander is in MCP23S17 microcircuit. I unsoldered it on a separate board, which made it possible to assemble the entire breadboard. We collect this circuit with wiring and see how it works. Power is on and apply it to the touch button. We make a few touches. Each touch is recorded by the microcontroller and sent back to the input-output expander on its indication port. The LEDs are connected to port A of the expander. The button is connected to one of the pins of port B of the expander. Most importantly, this expander uses only 4 pins of the microcontroller, allowing 16 pins to work. In this case, 8 pins are used for the output to control the LEDs and 1 pin for the input to read the signal from the button. Let's move on to the electrical diagram. The connection is based on the datasheet for the expander. The pins of expansion, power supply, and address control are used. The circuit contains practically no details, except for the resistor on the reset line. 4 interface lines required for communication with the STM32 microcontroller. It controls and receives information via SPI2. The data source is a touch button. The data receiver is a set of red LEDs. Let's move on to programming. In the main function, we configure the peripherals. For the special object MCP23S17, we indicate the hardware address, the chip selection line, and the SPI interface. The basic work cycle is pretty straightforward. We read a port B bit from the microcircuit. If its state has changed, when we check what it is. If a button is pressed, when we increase the internal byte for port A, set its value to port A. And so it happens all the time in this endless cycle. To read a bit, first read the entire port value for that bit, then apply a mask and return the actual value. In order to write a byte, we configure all the pins of the port to output and set the specified value to the port. The SPI input-output function with input-output expander works as follows. We form a buffer for writing, indicated the hardware address and the read-write flag. This view is reflected in the datasheet. There is also a permanent prefix here. We reset the CS signal. We configure DMA channels depending on the SPI used. We launch DMA and wait for it to work. We return the value received from the expander. And one more important note, do not forget to enable clocking. And that's all for today. In the next video we will connect a keyboard and a 7-segment indicator. See you in the next video. Subscribe, microcat.